All right, here we go. This is section 9.4. There's two sections here, the two separate videos, one for solving using square roots and one for solving using factoring. So here we're going to be talking about quadratic equations in more detail. Remember, a quadratic equation is something of the form x squared. If it's just y equals x squared, it's really simple and basic. It has an intercept at 0. But when we shift them and stretch them and shrink them and reflect them, it can get a lot more complicated. So this is going to be a technique that we have to finding the zeros or roots or x-intercepts for a quadratic function. And it's going to involve factoring and then using the zero product property. So when you factor a quadratic, you have it in the form y equals a times x minus r1 and then x minus r2. And the reason it's written like this is because r1 and r2 are the two roots. But sometimes it's maybe a little bit not coming in this form. So what do? Well, you have to factor the polynomial as a product of two things. And then remember that to find the intercepts, you're setting y equal to 0. So now we have this thing called the zero product property, which we've actually kind of already been using, but we'll formalize it here. When you multiply two things together, or in this case, three things together, and the answer comes out to be 0, the only way that you can do that is if one of these is 0. It might be 0 times 0 times 0. Two of them could be values. As long as one of those is a 0 somewhere, the overall answer is going to pop out as a 0. So what we can conclude is if the outcome is a 0, one or more of these inputs had to be 0. And then we can separate them off and say, okay, let's solve the equation. This one equals 0. What do we get? Let's solve the equation here. This one equals 0. What do we get? Solve the equation here. This one equals 0. What do we get? And the truth is, A cannot be 0 because you can't have like 5 equals 0 or 2 equals 0. So this one's not going to give us any solutions. But this one is going to give us a solution, x equals r1. And this is going to give us a solution, x equals r2. So you can see the reason why the roots, aka zeros, aka x-intercepts, are at the value r1 and r2 is because of this thing called the zero product property. Okay. So let's take a look at what it looks like in action. Actually, let's take a look at a reminder first. What are all the ways we can factor something? So this only works if you have it in factored form. So if the problem starts off in standard form or some other form, you're going to have to do some work to get it into factored form first, and then you can apply that. So we learned 4 different ways to factor in the preceding sections. The first one is using the distribution property. If you have 4 terms, you can group the second 2 and group the first 2, and then do factor by grouping to get a result. If you have a quadratic trinomial, you're looking for 2 numbers that multiply to C and add, let me write that, multiply to C and add up to B. Once you figure out what those 2 numbers are, you can put them here for M and for P. It's a little bit more complicated if you have a coefficient in the front, but just go back and maybe check your notes to remind yourself on that. Then you've got a difference of squares, which you have to recognize. If it's something squared minus something squared, it's always 1 plus 1 minus, but the same numbers. So a times a is a squared, b times b is b squared, and the middle terms are positive ab and negative ab. Those cancel out, which is why the middle term cancels out. Then you have perfect squares, on the other hand. These always do have a middle term that's 2ab, either positive or negative, depending on whether you had positive or negative over here. So I'm not going to go through this in detail because this is a reminder. But once you finish factoring it, you can then use that along with the zero product property to solve some problems. Let's look at some quick examples, and then this video will be finished. So to use the zero product property, or take a square root, depending on what you have to try to get this thing equal to 0 or with a squared by itself. So here's an example. We could subtract 16 on both sides. And then we're going to have d squared equals 60 minus 16. Yowza. What does that equal? 50, 44. Then we could take the square root of both sides. And we could say d equals plus or minus, because we have to remember 2 possibilities. The square root of 44, that's going to be 4 times 11. So that's going to be 2 root 11. So this is an example where you're solving it by taking the square root of both sides. This one is another example where you're solving by taking the square root of both sides. So it can be something like this, where you take the square root, and you get p minus 15 equals plus or minus. And now here, square root of 121 is 11. Okay, so now you go plus 15, plus 15. Now it's going to be 15 plus or minus 11. You can't leave your answer like this. If it has a radical in it, you could leave it as something plus or minus. But if they're just whole numbers, you got to actually do it. So 15 plus 11 is 26, and 15 minus 11 is 4. So our two answers are 26 or 4. So we need to actually compute the values when you can in their whole numbers. So that's kind of like a reminder and review of solving by taking the square root. These over here, I think, will be better for us for this section. If it's already factored for you and it's equal to 0, you can simply take the two pieces and say, hey, maybe this is equal to 0. So 7x plus 3 equals 0. Solve this, minus 3, and then 7x equals minus 3. Then divide both sides by 7, and you get x equals negative 3 over 7. Or on the other hand, maybe this part is equal to 0. 2x minus 6 equals 0. Add 6 to the other side. So you get 2x equals 6 because we did plus 6 plus 6. Then divide by 2 and you get x equals 3. So we get two answers. Both of these are possibilities. And when you graph it, it's a parabola, of course, remember that it's going to cross usually two different times. Let's take a look at 34. Yowza. So the first thing you might notice in number 34 is there's a coefficient there, but we got lucky. All of these are even numbers, so we can divide everything by 2. So if we divide everything by 2, we're going to get y squared minus 13y plus 40 equals 0. So now I'm looking for two numbers that multiply to 40 and add up to 13. Huh. Well. That doesn't seem to work out too well, does it? So they both have to be negative. So let's think about our values. 4 and 10 is too big because 4 and 10 is 14. So what if I go 5 and 8? Aha, 5 and 8 works out. So y minus 5, y minus 8 equals 0. So 5 times 8 is 40, 5 plus 8 is 13. Both are negative. So now I can branch it apart. You don't have to show this work if you don't want to. Y minus 5 equals 0. Move the 5 over and you get y equals 5. Y minus 8 equals 0. Move the 8 over and you get y equals 8. As long as you don't have any coefficients in here, you know you're just going to take the opposite of what you see. And you can do that step in your head if you want to. If you have coefficients, like here we had a 7x and here we had a 2x, it's probably good to actually pull it apart and show your work so you can see what you're doing. But yeah, anyway, so this is how you do them. Factor it out, use a zero product property, get your two solutions. If it's a quiz or a test, plug those back in, make sure that they work, and you'll be all set. Sounds good, guys. See you in class.